Relative Gravity Class 1, The Evolution of Cosmological Thought and the Emergence of the Thermodynamic Universe.
The quest to understand the origins and mechanics of the universe has been a central pursuit of both science and philosophy. Traditional cosmological models, such as the Big Bang Theory and general relativity, provide a framework for explaining cosmic evolution, but leave fundamental questions unanswered, chief among them the nature of existence before the Big Bang and the driving forces behind cosmic expansion. The Genesis framework, as proposed in this work, challenges the notion of a singular origin event and instead presents the universe as an iterative, self-regulating system governed by principles of relative gravity, multiversal interactions, and harmonic equilibrium. Drawing from both ancient Eastern philosophy and modern physics, this framework posits that the void is not an inert emptiness, but a dynamic field of latent potential. The delta phenomenon, a core principle of this model, describes how structured reality emerges through continuous differentiation, leading to stable formations such as subatomic particles, galaxies, and entire universes. Rather than a linear expansion into entropy, the cosmos operates through cycles of growth, contraction, and rebirth, governed by the interplay of force, impedance, and relative equilibrium. In this view, gravity is not merely a function of mass, but an emergent property of manifold interactions across space-time. A critical extension of this model is the infinity manifold, which situates our universe within a broader multiversal structure. Instead of existing in isolation, universes are proposed to be interconnected through fundamental mathematical relationships, allowing for interactions that shape cosmic evolution. This approach provides a compelling reinterpretation of dark matter and dark energy, suggesting that they may not be separate entities, but manifestations of inter-universal forces balancing cosmic structures. Likewise, quantum fluctuations and entanglement are seen as evidence of multiversal resonance, bridging gaps between classical and quantum physics. The Genesis framework aims not only to refine our understanding of the universe's origins, but also to redefine fundamental forces and interactions in a way that aligns with both observational evidence and theoretical advancements. Through computational modeling, gravitational wave analysis, and high-energy physics experiments, the principles outlined in this work can be empirically tested. By moving beyond singularity-based paradigms and embracing a continuously evolving cosmos, this theory provides a novel and unifying perspective, one that challenges existing dogma while offering new pathways for exploration in physics, cosmology, and beyond. By Orion Carl Daly 5. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe Abstract. This paper presents a unified framework for understanding the origin of the universe as an iterative emergence from the void, drawing on both ancient Eastern philosophical insights such as those found in Tibetan Buddhism and modern physics. Proposed is that the void is not an inert emptiness, but a dynamic field of latent potential. Through the interplay of the dimension of time and the delta phenomenon, this framework describes how iterative differentiation processes give rise to structured existence, marking a continuous genesis that recurs cyclically in cosmic evolution. 1. Introduction: the philosophical and scientific genesis. The concept of genesis, creation from nothing, has been a subject of inquiry across various cultures and scientific disciplines. In Tibetan Buddhism, the void or sunyata is viewed not merely as an absence of form, but as the fertile ground from which all phenomena emerge. Modern physics, particularly in quantum mechanics and cosmology, has similarly challenged the idea of a static void by revealing underlying fluctuations and potentials within what science once considered empty space. In this paper, explored is how the void, when processed through the dimension of time and transformed via the delta phenomenon, yields a continuously unfolding genesis, where a system based on available resources is able to support itself. This iterative process leads to the emergence of complex structures, from subatomic particles to entire galaxies. 1.1 The nature of the void, a dynamic origin. The concept of the void has been contemplated for millennia, spanning both ancient philosophical traditions and modern scientific inquiry. In Tibetan Buddhism, sunyata, emptiness, is not merely an absence of form, but a state of potentiality, an ever-present dynamism from which all phenomena emerge. Similarly, in contemporary physics, what was once perceived as empty space is now understood to be filled with quantum fluctuations, wave interactions, and latent forces. From both perspectives, the void is not an inert vacuum, but a field rich with hidden structure, a fertile ground for existence itself. This raises the fundamental question: how does form arise from the void? 1.2 A dynamic void, why nothingness is not empty. Instead of treating the void as a static absence, proposed is that it is governed by intrinsic fluctuations, subtle variations in energy density, temperature, and wave interactions that seed the emergence of structure. The idea that absolute nothingness can exist contradicts both quantum mechanics and ancient metaphysical insights. By Orion Carl Daly 6. Cookbook for the Universe. Rather than a void of absolute emptiness, what exists is a primordial field of latent energy, where Temperature fluctuations create minute differentiation within the void. Microscopic variations propagate as waves, forming the first patterns of structure. Time emerges as a consequence of changing states in these fluctuations. These principles set the foundation for the evolution of form, leading to the emergence of structure, force, and eventually, singularity formation. 1.3 The first evolutionary step, the role of temperature fluctuation. In the earliest state of existence, without objects or forces, differentiation begins with temperature shifts at the microscopic level. These fluctuations serve as the first differentiating factor, breaking the homogeneity of the void and allowing for the formation of wave dynamics, subtle ripples that create patterns within the void. Relative reference frames the concept that locations within the void become distinct based on energy variations. The initiation of time as temperature shifts, time emerges as a function of sequential differentiation. Through these interactions, the void ceases to be an undisturbed expanse and instead becomes a dynamic medium, capable of generating structure. 1.4 The evolution of form, from fluctuations to structure. From this fundamental instability, the process of form building begins. 1.4.1 Wave interactions. Microscopic fluctuations create oscillatory patterns that interact and reinforce specific structures. 1.4.2 The formation of cyclic equilibria. As fluctuations stabilize into repeating wave patterns, they form self-regulating cycles, the precursor to structured emergence. 1.4.3 Manifold formation. These cycles evolve into distinct regions of relative force and energy, the first expression of manifold structures. 1.4.4 Iterative growth through the delta phenomenon. Each emergent structure undergoes recursive differentiation, allowing for complexity to build layer by layer. The development of relative mass and force fields. As iterations continue, the relationships between different manifolds define what will later be recognized as mass, energy, and gravitational interactions. By Orion Carl Daly 7. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 1.4.5. The emergence of a singularity. Rather than beginning as a singular, condensed point, the singularity evolves as a culmination of prior iterations, forming as a result of balanced forces within the expanding manifold. 1.5 A new perspective on singularity formation. Contrary to traditional Big Bang cosmology, which assumes a singularity existed as a precondition, this framework proposes that singularities emerge from the iterative refinement of force interactions, not as an initial condition, but as an end state of structured evolution. The singularity is not a static point but an evolving entity, existing in equilibrium within the larger manifold structure. Space and time are emergent properties, not absolute prerequisites, forming naturally as differentiation progresses. Setting the stage for Section 2. Before delving into the specific mechanics of emergence, it is essential to recognize that the singularity does not appear spontaneously, but evolves through structured differentiation. By examining the void through the lens of dynamic fluctuations, wave interactions, and iterative refinement, we gain a more comprehensive understanding of how existence itself manifests from an origin that is never truly empty. This perspective reshapes our view of the nature of reality, the origins of time, and the formation of structured forces. In the following sections, we will expand on this foundation, introducing the dimension of time as the driver of emergence and the delta phenomenon as the mechanism by which form evolves from structured cycles of iteration. By Orion Carl Daly 8. Cookbook for the Universe 2. The dimension of time as the engine of emergence. Time is more than a passive measure, it is the medium through which transformation occurs. Posited is that the passage of time is the critical factor that differentiates the void into progressively more structured states. Formally, let MT represent the state of a manifold emerging from the void at time t. Its evolution can be captured by, which serves as a formal representation of how change is governed by temporal progression. 3. The delta phenomenon. Iterative differentiation. The delta phenomenon embodies the principle that each new state of existence arises as an incremental modification of its predecessor. We denote the initial void state as M0. The evolution of the system can be recursively defined as Mn plus 1 equals delta Mn plus Mn, where delta Mn represents the operation of differentiation both metaphorically and mathematically applied to the prior state Mn. This recursive process captures the notion of genesis as a continuous, cyclic reemergence of form from the void. 4. Mathematical mechanics of the emergence process. We can describe the formation of structured manifolds using an impedance-based approach, where the void encounters resistance that gives rise to expression. Given a vector field that describes relative force, Z equals to md plus alpha m, where represents an impedance factor. The emergence of stable formations occurs when to integral tfcr equals mf m0. To test the model, computational simulations can be employed. By setting initial conditions that represent the void M0 and using differential equation solvers, one can simulate the iterative process of emergence. Adjusting the impedance parameter alpha enables the observation of various self-organizing structures, which can be compared with empirical data from cosmic microwave background radiation and galaxy distribution studies. Preliminary simulation results indicate that iterative applications of the delta phenomenon yield stable, self-organizing systems, mirroring cosmic phenomena observed in nature. 6. Computational simulations and implications for modern physics and cosmology. This section refines computational simulations by incorporating multiversal modeling and how these simulations can validate the principles of relative gravity and the delta phenomenon. By setting initial conditions that represent the void and using differential equation solvers, one can simulate the iterative process of emergence. Adjusting the impedance parameter enables the observation of various self-organizing structures, which can be compared with empirical data from cosmic microwave background radiation and galaxy distribution studies. In addition, this section replaces traditional expansion models with dynamic equilibrium, where universes cycle through phases of growth and retraction. Using principles from the delta phenomenon, we can explore the balance between impedance and force emergence within relative fields, how cosmic waves and resonant frequencies influence universe-scale oscillations, the role of harmonic mean relationships in regulating cosmic structures. Furthermore, this framework suggests that the universe's origin is not a singular Big Bang event, but rather a sequence of iterative emergencies, each cycle reprocessing the void into a new state. 6.1 Key implications include relative gravity and structured emergence. Gravitational forces may be seen as emergent properties resulting from time-differentiated manifold layers, reshaping our understanding of spacetime curvature. By Orion Carl Daly. 10. Cookbook for the Universe. Quantum fluctuations as micro-iterations. The vacuum fluctuations in quantum mechanics can be reinterpreted as minute iterative processes of the delta phenomenon. Dark matter and energy. The impedance factor might also account for phenomena such as dark matter and dark energy, acting as moderators in the emergence process. Through these computational approaches, relative gravity and the multiversal framework can be tested and refined to bridge the gap between theoretical predictions and observational data. 7. Expansion and contraction of the universe. Here explored is how cosmic evolution follows a dynamic, cyclic pattern, challenging traditional expansion models. Instead of a single inflationary event leading to perpetual expansion, relative gravity and the delta phenomenon reveal a universe that undergoes continuous cycles of growth and retraction, shaping the very fabric of reality. This cyclic nature suggests that the universe is self-regulating, adapting through harmonic balancing mechanisms that ensure structural stability over time. 7.1 Key mechanisms governing expansion and contraction. 7.1.1 Harmonic mean relationships, the mathematical balance of cosmic oscillations. Traditional models often depict cosmic expansion as a function of dark energy, but harmonic mean relationships suggest a more fluid and self-adjusting mechanism. By treating universal growth as an oscillatory function, relative gravity predicts naturally recurring expansion and contraction phases, governed by harmonic resonance between mass-energy distributions. This mathematical balance mirrors wave-like interactions found in atomic structures and planetary orbits, indicating that cosmic evolution follows similar principles. 7.1.2 Impedance balancing, regulating the flow of universal energy. Impedance balancing serves as a moderating force, preventing uncontrolled expansion or gravitational collapse. Just as electrical circuits use impedance to control current flow, the universe appears to use gravitational impedance to balance energy exchanges across manifold structures. The presence of dark matter and dark energy may be reinterpreted as emergent properties of impedance fields, ensuring that the cosmos remains within a sustainable energy distribution state. By Orion Carl Daly. 11. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. 7.1.3 Self-regulating cosmic cycles, the universe as an adaptive system. Expansion and contraction do not occur in isolation, but interact through manifold feedback loops, which help correct large-scale imbalances. Instead of an inevitable heat death, the relative gravity model suggests cosmic rebirths, where each contraction phase generates the conditions for a new expansion cycle. Observational evidence, such as large-scale structure formations, cosmic void distributions, and variations in cosmic microwave background radiation, may provide hints of prior cosmic cycles. 7.1.4 Implications for cosmology and multiversal interaction. Reinterpreting dark energy. Instead of a mysterious force driving perpetual expansion, dark energy may be the result of an oscillatory balance mechanism, shifting between expansion and contraction phases. Multiversal resonance. The cyclic nature of expansion suggests that universes may resonate with each other through frequency-based interactions, akin to the principles outlined in the radio station analogy. Future of our universe, if expansion slows and reverses, leading to a phase of contraction. This framework suggests that our universe could be part of an ongoing evolutionary loop, where it periodically resets in a new manifestation. 7.1.5. Conclusion. The expansion and contraction of the universe are not isolated processes, but part of a grander, self-regulating mechanism governed by relative gravity and the delta phenomenon. By integrating harmonic mean relationships, impedance balancing, and cyclic evolution, this model presents a compelling alternative to singular expansion theories, framing the universe as a dynamic, evolving system rather than a one-way trajectory. Future observations of gravitational wave distortions and large-scale cosmic structures may provide the necessary empirical validation for this cyclic framework. By Orion Carl Daly 12. Cookbook for the Universe 8. The initial frame of reference, the key to emergence. What gives rise to the fabric of reality? Before the universe can evolve, before the vast web of galaxies can form, there must be an initial frame of reference, a foundation upon which all motion, transformation, and emergence occur. This section delves into the profound question of how universes emerge relative to their own unique frames of reference, and how these fundamental organizing principles shape cosmic evolution. At the heart of this discussion lies the realization that space and time do not exist in isolation. Rather, they emerge from a self-referential process, where each universe establishes its own fundamental coordinates. This dynamic interplay of force, time, and energy creates the scaffolding upon which all physical laws operate. 8.1 Key elements of the initial frame of reference. The birth of a frame. What preconditions must exist for a universe to establish its initial point of reference? This explores how relative equilibrium and the interplay of energy manifolds give rise to structured reality. Cosmic blueprints. How do reference frames govern the evolution of cosmic structures? Here we can examine how different universes can develop distinct laws of physics depending on their foundational reference frame. The nexus of time and force, the interwoven nature of relative force, time, and energy suggests that the genesis of any universe is not arbitrary but follows a self-organizing principle. This section explores the role of relative gravity in structuring the emergence of space-time itself. By understanding the initial frame of reference, we can uncover the fundamental architecture that enables universes to take form, setting the stage for cosmic interactions, expansion, and the emergence of order from the void. By Orion Carl Daly 13. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 9. The Infinity Manifold, a Bridge Between Universes. Beyond the boundaries of a single universe lies the concept of the infinity manifold, a structure that interconnects multiple universes through fundamental mathematical and physical principles. Rather than treating universes as isolated entities, the infinity manifold provides a framework for understanding how they share properties, exchange energy, and maintain equilibrium through an intricate web of interactions. 9.1 The role of the infinity manifold in cosmic structure. At its core, the infinity manifold describes how universes exist not as singular, self-contained realities, but as interconnected manifolds that overlap in a higher dimensional framework. Each universe operates with its own relative equilibrium, yet these equilibria are not static, they influence one another, creating a dynamic interplay that extends beyond any single universe's observable limits. 9.2 Key aspects of the infinity manifold. Superposition of universes. Universes can exist in a state of quantum-like superposition, where their properties overlap under certain conditions. This concept suggests that multiversal interactions may follow wave interference patterns, influencing energy distributions and force dynamics across universes. Relative equilibrium and stability. Just as celestial bodies maintain orbital stability through gravitational relationships, universes within the infinity manifold maintain coherence through relative equilibrium. This prevents uncontrolled collapse or chaotic divergence, ensuring structured multiversal evolution. Manifold intersections and energy exchange. At the intersections of manifolds, energy, information, and even matter may transfer across universes. These exchanges may occur through tunneling effects akin to quantum mechanics, or via higher-order topological relationships in spacetime, where different reference frames momentarily align to allow for controlled transference. 9.3 Mathematical framework of the infinity manifold. To describe interuniversal interactions mathematically, extended is the concept of manifolds in differential geometry, applying principles of tensor fields, governing the relationships between universes by defining how their energy distributions curve and interact. Topological connectivity, using n-dimensional embeddings to describe intersections between universes and how these points facilitate energy transfer. Harmonic oscillations in interuniversal relations, just as atomic structures stabilize through resonant energy states. Universes may stabilize within the infinity manifold through synchronized oscillatory relationships. By Orion Carl Daly 14. Cookbook for the Universe 9.4 Implications of the Infinity Manifold. The concept of the infinity manifold not only provides a theoretical bridge between universes, but also offers possible explanations for observable cosmic phenomena, such as dark energy as an inter-universal force, if universes are exchanging energy. What is perceived as dark energy could be the result of forces balancing across the infinity manifold. Multiversal tunneling and high-energy events. Some high-energy cosmic phenomena, such as gamma-ray bursts, may originate from inter-universal interactions where energy momentarily tunnels from one manifold into another. Quantum gravity and unification. The infinity manifold provides a potential unification model that incorporates gravity, quantum mechanics, and cosmic expansion into a single framework. 9.5 Conclusion. By framing the universe as part of a larger, interconnected multiversal system, the infinity manifold challenges conventional cosmology and extends the principles of relative gravity to a broader scale. Rather than an isolated cosmos, reality may function as an infinitely complex and evolving network, where universes share properties and influence one another through mathematically describable interactions. Future exploration of the infinity manifold will require both theoretical advancements in higher dimensional mathematics and observational breakthroughs to detect evidence of inter-universal phenomena. By Orion Carl Daly 15. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 10. The Chemistry of the Universe. At the smallest scales, the chemistry of the universe is the foundation upon which all structure is built. The interactions of fundamental particles give rise to the vast complexity observed at cosmic scales. This section explores how the fundamental building blocks of matter influence not only the formation of galaxies and stars but also the structural principles of entire universes. 10.1 The role of fundamental particles in structuring matter across universes. Subatomic symmetry in matter formation, the conservation of charge, spin, and mass-energy relationships among fundamental particles plays a crucial role in determining the large-scale distribution of matter across multiple universes. Oriogenesis and the balance of matter and antimatter. The conditions necessary for the predominance of matter over antimatter in our universe may not be arbitrary, but rather a function of multiversal symmetry breaking within the infinity manifold. Neutrinos and universal cohesion. Neutrinos, due to their near masslessness and weak interactions, may serve as carriers of information across universes, influencing how matter coalesces over cosmic time scales. 10.2 How relative mass changes under different reference frames. Mass is a function of relative equilibrium. Within relative gravity, mass is not an absolute quantity, but a property influenced by its relationship to surrounding energy fields and reference frames. Mass-energy conversions across universes. If universes are interconnected via the infinity manifold, the apparent constancy of mass in one universe may be dynamically related to its fluctuating energy density in another. The role of impedance in mass shifts. Just as electrical impedance affects current flow, cosmic impedance, the resistance to force propagation within a given universe, can affect mass equivalence across reference frames, potentially explaining anomalies in dark matter distributions. 10.3 The connection between subatomic properties and large-scale cosmic evolution. Quantum fluctuations as seeds of cosmic structure. The initial quantum perturbations in a universe's formative stages may be resonantly linked to adjacent universes, guiding the emergence of large-scale structure through harmonic relationships. The role of strong and weak nuclear forces. These forces dictate atomic stability, but their fine-tuning may extend beyond a single universe's boundary, affecting how fundamental elements distribute across different cosmological settings. By Orion Carl Daly 16. Cookbook for the Universe. Dark matter as a multiversal artifact. If matter behaves differently across universal boundaries, dark matter might represent a shadow effect, a gravitational imprint of mass existing partially within another reference frame. 10.4 Implications for cosmic chemistry and multiversal interactions. Chemical evolution as a universal constant. The periodic table of elements may not be fixed across all universes. Instead, different physical laws governing nuclear synthesis in adjacent universes could give rise to alternative chemical landscapes. Inter-universe elemental transference. If energy can transfer across the infinity manifold, it is plausible that exotic elements or novel atomic interactions exist beyond the scope of our universe, only detectable under extreme conditions. Gravitational chemistry. The role of gravity in facilitating chemical complexity, such as star formation and molecular cloud interactions, may itself be a function of the relative reference frame, influencing how chemistry unfolds at cosmic scales. 10.5 Conclusion. The chemistry of the universe is not merely a consequence of particle physics but a dynamic, evolving feature of relative gravity and multiversal interactions. Understanding how fundamental particles behave across reference frames allows us to not only explain the origins of mass and structure, but also to explore the vast possibilities of how chemical processes might unfold beyond our own universe. Future exploration into multiversal chemistry, interuniversal matter exchanges, and alternative periodic tables will be key to uncovering the true nature of cosmic matter formation. By Orion Carl Daly, 17. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. 11. The Multiverse Hypothesis, the Crystal Ballroom Analogy. Imagine stepping into a grand hall, filled with an infinite number of crystal balls, each reflecting and refracting the light from every other ball around it. This crystal ballroom analogy offers a powerful visualization of how multiversal reflections influence universal evolution, suggesting that each universe is both distinct and yet interconnected through a web of interactions governed by fundamental principles of relative gravity and quantum entanglement. 11.1 The role of multiversal reflections in cosmic evolution. Universes as mirrors of each other, just as light bounces infinitely between mirrored surfaces. Energy fluctuations and quantum states in one universe may subtly echo into adjacent universes, creating a cascading effect that influences cosmic structure across multiple realities. The resonance effect. If universes are connected through harmonic oscillations, their collective frequencies may shape the rate of cosmic expansion, galaxy formation, and even the emergence of fundamental forces. The interplay of chaos and order. While universes evolve independently, their interactions may introduce elements of deterministic chaos, where the behavior of one universe is subtly nudged by changes in its multiversal neighbors. 11.2 Quantum entanglement and interuniversal interactions. Entanglement beyond one universe. Traditional quantum mechanics suggests that entangled particles share instantaneous connections across space. The multiverse hypothesis extends this principle, suggesting that entanglement could span multiple universes, allowing for information to persist beyond a single cosmic boundary. The overlap of probability waves. Universes may interact not through direct physical contact, but via probabilistic wave interference, where the collapse of a quantum state in one universe influences the probabilities in another. Multiversal coherence and decoherence. Just as quantum systems experience coherence and decoherence, entire universes may shift between states of greater and lesser alignment, altering the nature of physical laws and constants over time. By Orion Carl Daly, 18. Information is a persistent field. If information is fundamentally conserved across reality, it may manifest as a subtle but persistent field that connects universes, influencing cosmic structures and even evolutionary pathways for matter and energy. Gravitational imprints as messages. Just as ripples in space-time left by gravitational waves encode events from billions of years ago, similar distortions could serve as multiversal messages, carrying signals from one universe to another. Dark matter is a shadow of multiversal information. The unexplained presence of dark matter may be the result of gravitational influences from adjacent universes, where the mass-energy relationship slightly leaks into our observable cosmos. 11.4 Implications of the Crystal Ballroom Model. Expanding the theory of everything. If universes influence one another through reflections, then any complete theory of everything must incorporate interuniversal principles alongside quantum mechanics and relativity. Time is a nonlinear construct. Multiversal reflections suggest that time, rather than flowing in a singular direction, may be multidimensional, allowing certain interactions to ripple backward or forward depending on the frame of reference. The search for multiversal evidence, advanced studies in gravitational waves, dark matter anomalies, and cosmic background radiation may offer hints of interuniversal reflections, guiding future experiments in physics and cosmology. 11.5 Conclusion. The crystal ballroom analogy presents a compelling way to conceptualize multiversal interactions. Instead of viewing our universe as an isolated entity, this model suggests that reality is a vast hall of interconnected reflections, where the subtle influences of adjacent universes shape the grand structure of existence. As our understanding of quantum mechanics, gravitational interactions, and information theory deepens, we can move closer to uncovering the true nature of the multiverse and its profound implications for existence itself. By Orion Carl Daly, 19. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. 12. The radio station analogy, frequency tuning and universal properties. Imagine the universe as part of a vast cosmic radio spectrum, where each universe operates on its own resonant frequency, much like individual radio stations broadcasting on different wavelengths. This radio station analogy provides an intuitive way to understand how multiple universes can coexist, influencing one another without direct interference, while still maintaining distinct identities. 12.1 Universes as frequency-based realities. Resonant frequencies define existence. Each universe can be thought of as broadcasting on a unique vibrational frequency, dictated by its energy density, space-time curvature, and fundamental constants. These frequencies prevent universes from overlapping in a chaotic manner while allowing for structured interactions. Interference and signal leakage, while universes typically remain separated by their distinct frequencies. Subtle signal leakage akin to hearing faint signals from adjacent stations on an old radio may allow for information exchange and gravitational interactions across universes. Multiversal harmonics, just as musical notes combine in harmonic structures. Universes may be arranged in a harmonic sequence that defines their relationships. The spacing between their frequencies may determine the strength of inter-universal interactions. 12.2 How universes influence each other through frequency tuning. Synchronization events. Occasionally, universes may enter resonant alignment, where their frequency modulations overlap in a way that allows for transient interactions, similar to when two radio stations briefly overlap before returning to their original frequencies. Quantum wave interference across universes. The interference patterns between universes may manifest as subtle variations in cosmic background radiation or gravitational anomalies that have yet to be fully understood. Tuning the universal dial. If universes can shift frequencies over vast timescales, this might explain certain observed phenomena, such as phase transitions in dark energy or unexplained shifts in fundamental constants over cosmic history. 12.3 Implications of frequency-based universal properties. Dark energy as a frequency shift. If a universe's energy state shifts, altering its fundamental frequency, this could manifest as an apparent acceleration of cosmic expansion, offering an alternative explanation for dark energy. By Ryan Carl Daly 20. Cookbook for the Universe. Multiversal crosstalk. Just as radio waves can be modulated to transmit encoded information, universes may encode their interactions within subtle shifts in gravitational wave signals or vacuum fluctuations. Impacts on quantum mechanics. If universes exist within a frequency-based framework, then certain quantum behaviors such as entanglement or wave function collapse may be linked to inter-universal resonance effects, suggesting that quantum mechanics may be deeply intertwined with multiversal properties. 12.4 The search for cosmic frequencies. Gravitational wave detection. New experiments in gravitational wave astronomy may provide insight into the background hum of the multiverse, revealing potential frequency patterns that suggest inter-universal resonance. Fine structure constant variability. Studies tracking shifts in the fine structure constant over billions of years may provide evidence of tuning effects between universes. High-energy particle collisions. Experiments in high-energy physics, such as those conducted at the Large Hadron Collider, may inadvertently create conditions where cross-universal frequency interactions momentarily manifest. 12.5 Conclusion. The radio station analogy offers a new way of conceptualizing multiversal interactions, suggesting that universes operate like frequency-locked realities, influencing one another in ways we are only beginning to understand. If this model holds, future breakthroughs in gravitational wave research, quantum field theory, and cosmology may provide the first tangible evidence of inter-universal resonance, fundamentally reshaping our understanding of existence. By Ryan Carl Daly 21. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 13. The Four Laws of Relative Gravity, a Unified Framework. The four laws of relative gravity serve as the foundation for understanding how force, mass, time, and energy interact in a multiversal, manifold-based framework. These laws consolidate prior discussions into a single, unified model that describes the emergence, interaction, and evolution of universes. Unlike classical mechanics, which treats gravity as a function of mass alone, relative gravity provides a dynamic, scalable, and multidimensional interpretation of gravitational interactions across reference frames. 13.1 The Four Laws of Relative Gravity. 13.1.1 Relative mass is a product of relative force. Definition: mass is not an intrinsic property, but a relative expression of force distributed across a given reference frame. Implications: in different universes or manifold intersections, what is perceived as mass may vary depending on the nature of the reference frame and the impedance factors within it. Applications: this principle aligns with observations of dark matter and gravitational lensing, where unseen mass may be an effect of relative force distribution rather than an independent substance. 13.1.2 Relative equilibrium between mass and energy. Definition: the relationship between mass and energy is contextual and depends on the surrounding relative forces and impedance fields. Implications: this equilibrium allows for stable cosmic structures, preventing runaway gravitational collapse or excessive expansion. Applications: in cosmology, This principle explains why certain galaxies maintain their form despite insufficient visible mass, and why cosmic expansion may occur at different rates in different reference frames. 13.1.3 Manifolds as the organizing principle of structure. Definition: all cosmic structures, from particles to galaxies, can be understood as manifolds where force interactions define their dimensionality and behavior. Implications: this removes the need for singularities by replacing them with evolving manifold intersections that adjust dynamically to their environments. Applications: this principle provides a continuous model of cosmic formation, where the transition between energetic states follows a logical, iterative progression rather than abrupt, singular events like the traditional Big Bang model. By Ryan Carl Daly, 22. Cookbook for the Universe. 13.1.4 Time is a relative phenomenon. Definition: time is not absolute but rather a function of relative interactions between mass, energy, and force within any given reference frame. Implications: time can expand, contract, or shift depending on the frame of reference, affecting cosmic evolution, entropy, and even multiversal interactions. Applications: this principle offers a framework for understanding time dilation in extreme gravitational fields, variations in cosmic background radiation, and possible inter-universal tunneling where time behaves differently across manifold intersections. 13.2 How the four laws relate to universal structure and multiversal interactions. 13.2.1 Bridging classical and quantum mechanics. Unlike Newtonian gravity or Einstein's relativity, which apply specific models under limited conditions, relative gravity provides a framework that is applicable at all scales, from quantum fluctuations to galactic superclusters. The interplay of mass, force, and impedance explains quantum entanglement, vacuum fluctuations, and even how gravity may function at a subatomic level. 13.2.2 Resolving the dark matter and dark energy mystery. Dark matter may not be a separate entity, but rather an expression of relative force fields interacting across manifold structures, affecting the way mass is distributed. Dark energy may be a result of shifts in relative equilibrium, where mass-energy balance adapts to the evolving state of the manifold, leading to apparent cosmic acceleration. 13.2.3 Implications for multiversal expansion and contraction. The expansion and contraction of universes may be dictated by relative equilibrium states, rather than a one-time inflationary event. This offers a cyclic model of universal evolution, where universes shift through phases of expansion and contraction based on the distribution of relative forces. 13.2.4 New approaches to space travel and energy utilization. By manipulating relative force fields and impedance factors, future advancements in technology may allow for gravity-based propulsion systems that operate beyond conventional mass-energy limitations. The ability to harness relative mass fluctuations could lead to breakthroughs in energy generation, allowing the extraction of energy from inter-universal interactions. By Ryan Carl Daly, 23. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. 13.3 Conclusion. The four laws of relative gravity redefine our understanding of cosmic interactions, unifying gravity, quantum mechanics, and multiversal principles into a single framework. By viewing mass, energy, time, and force as relative and dynamic properties, this model removes inconsistencies found in traditional physics and provides a scalable foundation for future scientific advancements. The next step in exploring these laws lies in experimental validation through gravitational wave studies, quantum simulations, and high-energy physics experiments, which may ultimately prove the existence of relative gravity as the fundamental unifying principle of existence. 14. Implications for modern physics and cosmology. The theory of relative gravity challenges conventional physics by redefining the fundamental interactions governing the universe. This section consolidates previous discussions into a practical framework, outlining how relative gravity addresses the limitations of classical and modern theories, including general relativity, quantum mechanics, and the standard model of particle physics. 14.1 Gravity as an emergent force via manifold evolution. Beyond space-time curvature, unlike Einstein's general relativity, which defines gravity as the curvature of spacetime, relative gravity proposes that gravity emerges from the interaction of relative force fields within evolving manifolds. Dynamic mass-energy equilibrium. The intensity of gravity is not static but shifts in response to the evolving impedance of the surrounding manifold, explaining why gravitational interactions vary across cosmic scales. Superposition of gravitational fields. In a multiversal context, gravitational fields may not be strictly local, but could arise from a network of superimposed forces extending beyond a single universe. 14.2 Dark matter as impedance controlling expansion cycles. Dark matter as a multiversal artifact. Instead of a missing particle, dark matter is reframed as an impedance effect, where relative mass distribution is influenced by manifold interactions between universes. Stabilizing galactic structures. The reason galaxies do not tear apart despite their rapid rotation may not be due to an invisible substance but to a multiversal force counteracting centrifugal expansion. Predicting dark matter variations. If dark matter is a function of impedance, then its observed effects should correlate with regions of high relative force fluctuations, offering a new predictive model for astronomical observations. By Ryan Carl Daly 24. Cookbook for the Universe 14.3 Cosmic Expansion and the Role of Dark Energy. Relative equilibrium of expansion forces. The apparent acceleration of the universe may be caused not by an unknown dark energy, but by shifting equilibrium points in the cosmic manifold, where forces rebalance as universes evolve. Harmonic expansion and contraction. Just as oscillatory motion governs mechanical systems, the universe's expansion may be governed by harmonic mean relationships, suggesting a long-term cyclic pattern rather than a one-way expansion. Testing expansion models. Future cosmic observations may reveal that expansion rates fluctuate periodically, confirming the presence of underlying relative force fields rather than a singular inflationary force. 14.4 Quantum mechanics and the multiversal connection. Wave function collapse is a manifold shift. The collapse of a quantum wave function may not be an isolated event but rather a consequence of a manifold shift, where the particle's relative reference frame determines its observed state. Entanglement as a multiversal link. If universes exist as interacting manifolds, quantum entanglement may be evidence of information sharing across manifold intersections, challenging the idea of strict locality in physics. Revising the Standard Model. The properties of fundamental particles such as mass, charge, and spin may be dynamically determined by their relative positioning in the multiversal manifold, suggesting an evolutionary aspect to particle physics. 14.5 Potential for empirical validation through observational astronomy. Gravitational wave anomalies. If relative gravity is correct, gravitational wave detections should show subtle distortions not explained by general relativity, hinting at inter-universal influences. Fine structure constant variability. Observations of minor fluctuations in the fine structure constant over cosmic time may indicate shifts in the underlying relative force equilibrium. High-energy cosmic phenomena. The most extreme cosmic events, such as quasars, gamma-ray bursts, and black hole mergers, may serve as observational windows into inter-universal force interactions, providing measurable data points for testing relative gravity. By Ryan Carl Daly 25. Aka. Essay on Relative Gravity to Describe the Mechanics of the Universe 14.6 Conclusion. By integrating gravitational emergence, dark matter as impedance, and the role of inter-universal forces, relative gravity provides a comprehensive framework that extends beyond general relativity and quantum mechanics. This paradigm shift in physics not only redefines gravity, space, and time but also opens new pathways for empirical testing, ensuring that these theories remain grounded in observable, measurable phenomena. The next step involves designing experimental models and astrophysical observations that can confirm or refine the predictions of this revolutionary framework. 15. Conclusion. A refined view of Genesis. The quest to understand Genesis, the birth and evolution of the universe, has long been dominated by the traditional Big Bang model, which presupposes a singular origin event. However, by expanding beyond the singularity-based paradigm, presented is a more interconnected and iterative approach to cosmic emergence. 15.1 A new paradigm for understanding Genesis. Rather than relying on an arbitrary singularity to explain the universe's birth, this framework proposes that reality is shaped by self-organizing principles, governed by relative gravity, which unifies mass, force, and time as dynamically evolving properties rather than fixed absolutes; the infinity manifold, which provides a mathematical structure for multiversal interactions, ensuring that universes emerge and evolve through relational dynamics; the multiverse hypothesis, which suggests that universes are neither isolated nor unique, but rather part of an interconnected system where reflections, oscillations, and manifold transitions give rise to observed phenomena. 15.2 Key implications of this framework. Cyclic and iterative evolution. The cosmos does not emerge from a singular event but rather cycles through phases of expansion, contraction, and transformation based on equilibrium forces. Manifold-based structure of reality. The infinity manifold offers a structured explanation for how universes emerge as cohesive, evolving entities, rather than as isolated creations from a singularity. Gravity as an emergent and relative force. Unlike classical Newtonian or Einsteinian views, gravity is a property of relative equilibrium across evolving. By Ryan Carl Daly 26. Cookbook for the Universe. Manifolds, providing a new lens through which to interpret cosmological mechanics. Inter-universal interactions shape cosmic development. The influence of adjacent universes through gravitational resonance, frequency interactions, and manifold shifts suggests a reality that extends beyond the observable universe. 15.2 Rewriting the cosmological narrative. by incorporating relative gravity, the infinity manifold, and multiversal dynamics. This framework provides a rigorous alternative to traditional cosmology that is scalable across multiple reference frames, from quantum mechanics to cosmic expansion, capable of unifying gravitational phenomena, dark matter interpretations, and entropy considerations. Final thought: a continuously evolving understanding. This framework does not seek to impose a final answer, but instead offers a functional, evolving model that adapts as new discoveries emerge. Future research in gravitational wave physics, high-energy cosmology, and quantum information theory will serve as key testing grounds for validating or refining these principles. By embracing an iterative, interconnected approach to Genesis, we can take a step toward unraveling the deeper mechanics of existence, where the universe is not simply a product of chance, but a reflection of structured, evolving forces that shape reality itself. 16. Future work. The theoretical framework presented in this paper lays the foundation for a deeper exploration of relative gravity, the infinity manifold, and multiversal interactions. The next steps involve refining these ideas through computational modeling, experimental validation, and mathematical formalization. 16.1. Computational modeling of manifold-based cosmic expansion. Develop simulations that map the dynamics of manifold evolution, testing predictions related to expansion, contraction, and equilibrium states. Implement harmonic mean-based gravitational models to explore how relative forces regulate cosmic stability. Investigate the effects of multiversal resonance by modeling how interuniversal forces influence cosmic structure. By Orion Carl Daly 27. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 16.2. Experimental tests using quantum entanglement and multiversal interactions. Explore the possibility that quantum entanglement could extend beyond a single universe, potentially providing observable signatures of interuniversal connectivity. Design high-energy physics experiments to test for anomalies in particle behavior that may indicate manifold interactions. Investigate gravitational wave distortions for patterns that suggest multiversal interference or frequency-based universal alignment. 16.3. Further refinements to the mathematical framework of relative gravity. Expand on the tensor formulations of relative gravity, integrating additional variables for interuniversal force propagation. Refine the equations governing manifold intersections, ensuring they align with empirical observations in astrophysics and quantum mechanics. Develop a more precise mathematical description of relative mass, impedance, and reference frame-dependent gravitational interactions. 16.4. Cross-disciplinary applications and philosophical considerations. Apply relative gravity to biological, chemical, and cognitive systems, exploring its potential to describe emergent complexity in living organisms, artificial intelligence, and information theory. Investigate philosophical implications regarding the nature of time, consciousness, and existence, particularly in relation to manifold-based reality models. 16.5 Conclusion. The road ahead. The principles outlined in this work are not static but iterative, mirroring the cyclic evolution of the universe itself. The next frontier lies in developing testable hypotheses that bridge theoretical physics with empirical verification. As new discoveries in gravitational waves, high-energy physics, and quantum field theory emerge, relative gravity and the infinity manifold will continue to evolve, offering a revolutionary perspective on the very nature of existence. By Orion Carl Daly 28.